part 2, Screencast-O-Matic or wherever I'm using, limits me to 15 minutes. So we're going to crank through the last two MCs really quick. MC 31, which of the following protocols is used to establish a secured connection between a client and a web server? Whenever you see this lingo, you guys are the clients. You guys are the ones using the internet. A web server is just a server that is supplying you the documents that are needed for a particular website. So the question is, what of these protocols is used to make a secure connection? Be careful. A lot of these protocols we look at, we've heard of them, but it is actually the TLS handshake that is the very first protocol that's really utilized for that secured connection. The TLS handshake consists of utilizing both the asymmetric and symmetric encryption to make that really fast connection. Process: you would go to the website, you would ask for its public key, you would send them your secret password, but you would encrypt it with their public key. That website's servers then uses its own private key to decrypt the message that you had sent it, revealing the secret password. That secret password was sent from you, so you know what it is. It was received by the web server. They now know what it is. There was no way in between that somebody could have intercepted to read that message, so it is now a nice, safe, secure, secret message. From there on, you guys are using symmetric key encryption, which is the faster of the two, to really make those connections and those communications back and forth. When we look at number 2, this is again that TLS handshake that we're talking about. When you see that green lock in the HTTPS for us, that TLS handshake is just, again, that combination of using asymmetric and symmetric cryptography. Many of our cryptographic protocols are susceptible to that man in the middle. This is Eve trying to eavesdrop on our conversations. Let's take a look at this one in particular, where a man in the middle attack happens, and this is where digital signatures oftentimes help us out. You are trying to send a message to Bob, and so what you do is you grab onto Bob's public key. And what happens now, I think this is backwards. Suppose Bob tries to send Alice his public key. So Bob is trying to say, Alice, here's my public key. Can you please encrypt your message and send it to me? Well, Bob sends this thing out, and before it gets to Alice, Mallory or Eve, whoever you want to think of in this case, intercepts that message, sees that it's Bob's public key, and says, you know what, I'm going to send my own public key in place. So Alice is receiving what she thinks is Bob's public key, but it's actually Mallory's or Eve's or some other malicious user's. What's the possibility of happening from here? Well, what's probably going to happen is Alice is going to try and make a TLS handshake. Alice is going to come through and say, hey, here's the shared secret that I would like us to use. Problem? Bob's not the one she's sending it to. She is actually using the public key of Mallory or Eve or whoever's in the middle, so they could intercept those messages and now pretend or disguise themselves as Bob, thinking that they are making these secure connections, when really they're just sending it to some other malicious actor out of that. Be careful with that. Again, that is why digital signatures are oftentimes very useful in those. Phishing attacks. Phishing attacks are when you are trying to get lured into a trap, in a sense. These oftentimes happen via emails or text messages. We all get those stupid text messages that say, hey, your Twitter account, PayPal account is compromised. Click this link to double check your password. Please don't click that link. It is very likely a phishing attack. In that sense, they're trying to trick you into sending some sensitive information to a website that oftentimes looks like an appropriate website, but maybe doesn't have that green lock in the corner, or maybe there's some sketchiness about the layout of it. You always want to be careful and look for those precautions. Look for that lock that's in the corner. Make sure you guys are verifying the websites look like they do. These ones, you guys, the bots. The bots are everywhere on Twitter, on anything you go to, there's bots. Hey, the first person that replies to me is going to get $500. You just have to send me your banking information and I'll send it to you. Please don't send that online either to anybody. And the last one for this, a programmer is writing a program and is using a bunch of data sets. We're talking about what is the most likely to have a negative effect on my ability to process this large data set. With this, we're talking about big data here. So you have this massive data set. What is the number one hindrance of my ability to process this massively large data set? Well, let's look at some of the wrong answers first. Is where the data set coming from, does that matter? Remember, proprietary means that a company owns it. Publicly available data is something that is available to everybody. So whether a private company gives it or I find it on Google, does that affect how I process that data? No, not at all. If I get two identical data sets, one a proprietary and one a public data, they're both getting processed at the same exact speed. What about, we'll skip the right answer, what about the number of lines of code the program uses? That has an extremely minimal effect. And that is because the speed of electricity is so fast that adding one additional line or even thousands of additional lines is really nothing for a computer to handle. They can process those lines very, very, very fast for you. And what about if I write an algorithm with fixed memory requirements that doesn't vary with the size of the data set? Now, I just want to put this out here first. Look at those. Have we ever talked about writing an algorithm with fixed memory requirements? We have not. So a lot of times on these tests, I try to give you something that sounds very CS-y, but at the same time is something we have just never discussed in class. So in this situation, this is one of those that looks really good, but it really doesn't fit any of the criteria for the question. And again, the answer for this one is really how much processing power is needed for every entry that you have. That's the big key piece of this. If you're processing 1 million words, probably not too bad. If you're processing 1 million books, that's exponentially larger than 1 million words. So how much energy and time it takes to process one of your data entries can have a drastic impact on how then long it's going to take to process all of those data sets or all entries within that data set. That was the last one. Last one we got is MC number 32. Which of the following has contributed to the rise of big data? What about the increasing ability to collect those data sets? Yeah, we have more sensors everywhere in the world. We're collecting more data. Duh, there's a lot more data out there now. What about the development of machine learning? These are these algorithms that can learn and process data sets and find patterns that us humans couldn't. That sounds like a really good reason to keep finding data sets, large data sets, because we now have the technology to process those. And then what about the increasing availability from these, whether it's from data scientists, whether it's proprietary data? Again, there's just so much data out there being collected, being sent, being published for us that we really want to use all the means we have to process this stuff. So all three of these are actually contributing to the rise of big data. Problem number 2, I'll give you the general idea of this. You should be feeling comfortable about running through an algorithm of some sort and getting an output. This function says if I call it and I throw in the number 16, well, what's going to happen to it? Remember a while loop? As long as this statement is true, it's going to run one more iteration of the while loop and it comes back up and retries that. With this, the number 16 is larger than 0. Remember how modular division works. Modular division gives you back remainders. And when you modularly divide by a number and you check if the remainder is 0, the only way the remainder is going to be 0 is if this number is perfectly divisible by 3. So really in these questions, we're asking if this number is divisible by 3, add 1. Otherwise, if the number is divisible by 2, subtract 3. Otherwise, just subtract 10. So we have to really check just repeating a process. Is it divisible by 3? Is it divisible by 2? Okay, we've got 3 scenarios to run then. So let's run through it. 16. 16 is bigger than 0. Is it divisible by 3? No. Is it divisible by 2? Yes. Okay, my number 16 becomes the number 13. Run back to the top. 13 is bigger than 0. Is it divisible by 3? Nope. Divisible by 2? Nope. Okay, we're going to subtract 10 from it. It's now the number 3. Is 3 bigger than 0? Yes, it is. Is 3 divisible by 3? Yes, it is. We add 1 to it. Now it's the number 4. Come back up. 4 seems bigger than 0. Not divisible by 3. It is divisible by 2, though. So we will go ahead and subtract 3. My number is now the number 1. Come back up. Is 1 divisible by 3? No. Is 1 divisible by 2? No. Okay, I should subtract 10 from that number now. 1 minus 10 is negative 9. Come back to the top. Is negative 9 bigger than 0? It is not. Once we fail that test, it only takes one failure to kick us out. That's why we will give back that number, negative 9 there. Next up, Chase users want to transfer some funds from somewhere at chase.com. Which of the following cybersecurity is best, and it makes sure that I am at the chase.com website? I believe this is a good question to talk about. When we talk about digital certificates again, we have to make sure that we utilize a trusted certificate authority. And again, that's just validating this website owns these keys. So when you go through and you have Chase Bank's public key, you go to the certificate authority and say, does the public key they gave me match the public key that you have on file? If that does indeed match, your digital, quote-unquote, digital certificate is verified and checked off. Please go visit that website. It is a good website to go to. What precaution is most likely to protect an individual's privacy in large data sets? Let's go through some of those wrong answers, because I think these are good again. What if I take it off the web server and put it on a local hard drive? So it's not on the internet, but it's on my computer. Guess what? It's still sensitive information if someone accesses that hard drive. So probably not a good idea either. What if I just give them a policy and terms of agreement and say that, their data will be used to distributed to these other brokers? Everything about that sounds terrible, right? You don't want to trick somebody and just be like, hey, I'm taking your data, just sign your life away. Never a good idea. What about aggregating and storing the large data sets that consist of identifiable information? Big words here, like aggregate, but look at this. You don't want to be storing identifiable information anywhere. Instead, what would be nice is, what if I anonymized all the data? You're still getting all of it, but you just take out the first names, the last names, and you just keep all the information with numerical values to it. You can't replace that or get that back to the person who was originally given to. And last but not least, computer scientists in Boston, they want to draft this research paper from a colleague who lives really far away. It has sensitive information in it. What's the best way to share this? If you're far away, you're in a sense talking to strangers online. So again, you want to utilize asymmetric key cryptography or public key cryptography. Those are the exact same things. Symmetric would be very hard to do, especially with you having to have a shared secret. Caesar cipher, please never use that for online. That's like a fun tool to give a kid. And then a transposition cipher is another very, very weak one that we talked about in our notes, where we're just kind of shifting some letters, kind of similar to a Caesar cipher there. All in all, 5 multiple choices, 5 questions each. That was 25 questions. My gosh, there's 25 questions on your test tomorrow, I think, or on Wednesday. Everything should hopefully check out for you guys. If you have other individual questions, please feel free to email me. I will answer them as best I possibly can. Good luck, ladies and gentlemen. I'll see you guys on Wednesday.